So very good morning, my dear students. Here we'll discuss different elastic constants. Okay. So whenever a subject or a body is under axial tensile load, so there will be deformation along the length of the body or length of the object. Okay. So at the same time there will be a lateral deformation. Okay, there will be a lateral deformation perpendicular to the line of action of this axial tensile load. Okay, so here in this chapter we'll discuss these deformations, and there are different elastic constants like Young modulus, modulus of rigidity, bulk modulus, and we'll also discuss the different relation between the different elastic constants. Okay, so before we move to the different elastic constant, we should know the different terms related to the different elastic constants. Okay, so first of all we move for longitudinal strain. Longitudinal strain. So whenever axial tensile load is applied along the length of the body, so length will increase. So initially this length, then it will increase. So changing length, so we can say longitudinal strain, that is equal to change in length to the original length. Okay, that means the strain, we know the strain is changing dimension to the original dimension. Now along the length of the axis of this bar, the change in length by original length is called longitudinal strain. So along the length. Now another term, that is lateral strain. Now as soon as you apply the axial tensile load, the length of the bar is increased. So in the same time, if you consider other dimension, suppose breadth, width, so that will decrease. If length increase, other dimension that will decrease. So that we can say the lateral strain. So lateral strain will be here if del D is the change in diameter, or del B if you consider width or breadth. So we can say lateral strain del D by D in case of a cylindrical rod. So change in diameter to the original diameter. So change in diameter to the original diameter if you consider it as a cylindrical bar. Okay, now we'll go for relation between the longitudinal strain and lateral strain. So relation between the longitudinal strain and relation and the lateral strain is Poissons ratio. Okay, so what is Poissons ratio? Poissons ratio is lateral strain by longitudinal strain. Lateral strain by longitudinal strain. So that is defined by mu. So mu is equal to lateral strain by lateral strain by longitudinal strain, that also defined by 1 by m. So we can say lateral strain mu into lateral strain equal to mu into longitudinal strain. Now lateral strain is opposite to the longitudinal strain. Lateral strain is opposite to the longitudinal strain. So algebraically we can write lateral strain is equal to minus mu into else lateral strain is opposite to the longitudinal strain, so we can write lateral strain is equal to minus mu into longitudinal strain. So Poissons ratio, then lateral strain, longitudinal strain. Now this mu is varies from 0.25 to 0.33, and for rubber, for this is for metal and this is for rubber, 0.45 to 0.45 to 55. It varies in case of rubber. In this for materials, for metals. Okay. Now we'll discuss hydrostatic stress, volumetric strain, and bulk modulus. Okay, hydrostatic stress, volumetric strain, and bulk modulus. Now, if you consider an object and if you immerse this object in under the water, if you immerse this object under water, what will happen? So the water will create force along in different directions. Okay, so the stress generated in that particular object due to the water, so that stress is known as hydrostatic stress. Okay, that stress is known as hydrostatic stress. Now if you consider volumetric strain, so if you consider an object, which is under the action of a axial load, okay, which is subjected to an axial load P along the length. So initially if you consider L, B, then width, so you can see if you apply the load in axial along the length of this, so length will increase and width and breadth that will decrease. So we can say the volume will change, the volume of the object will change. Now what is volumetric strain? So volumetric strain is change in volume to the original volume. Now volumetric strain dV by V, okay, that is EV. So volumetric strain dV by V. Now initially if you consider the volume, original volume L, B, if you consider this is T, So T, original volume. Now due to the axial load, volume changes L plus del L. We only consider the change in volume. Okay, so L plus there is final length, then width B plus dB and T plus del T. So change so that is the final volume. Final, that means L plus del L, B plus del B and T plus del T. So change in volume. So change in volume, that will be L plus del L, then B plus del dV, then T plus del T minus L B T divided by L B T. Now L B T plus, we will consider del L B T plus del B L T plus del T L B, neglecting the product of smaller quantity. Okay, so that minus L B T divided by L B T. Now this L B T and that L B T will be cancelled. So finally we have EV is equal to del L BT plus del B TB of TL plus del T LB divided by LBT. So del L by L plus, if you divide, del B by B plus del T by T. So ultimately we have got volumetric strain V is equal to, so del L by L, if you consider in x direction, so Ex, del V by B in y directions, so you can consider Ey, and del T by T if you consider in z direction, so Ez. So you can write volumetric strain is equal to Ex plus Ey plus Ez. Okay, so that is the volumetric strain. Now hydrostatics, what is the relation between the hydrostatic stress with the volumetric strain? So if you consider hydrostatic stress sigma, hydrostatic stress, if you consider this sigma, so that hydrostatic stress is directly proportional to the volumetric strain. So hydrostatic stress is directly proportional to the volumetric strain. So this hydrostatic stress divided by EV, that is called bulk modulus. So bulk modulus is the ratio of hydrostatic stress to the volumetric strain. Now what is the significance of this bulk modulus? What is the significance of this bulk modulus? Bulk modulus is the which can that is the resistance of the material of the body without changing the form or size of the object. So it is the measure of the resistance of the material of the body without changing the form or the size of the object. Okay, that is the significance of this bulk modulus. Now, if you consider a body or object, and if you apply the shear force at the top of the object, okay, now what will happen? As the bottom end fixed, so top end will move from this to this. Suppose A, B, C, D. Now after deformation due to this shear force, so that is C dash, that is D dash. So that angle is phi. Okay. Now tan phi is equal to C dash divided by BC. So if this phi is very small, we can consider tan phi is equal to phi equal to C dash by BC. Now this is called shear stress. Okay, and that is called shear strain. So shear strain is the ratio of this C dash divided by the BC. This is called shear strain. Now there is a relation between the shear stress and the shear strain. Shear stress is directly proportional to the shear strain. Okay, so the shear stress, that is equal to C, or you can write G into phi. So C is equal to this by phi. This C is called modulus of rigidity. This C is called modulus of rigidity. Okay, modulus of rigidity. So modulus of rigidity, therefore, is called shear stress by shear strain. That is called modulus of rigidity. So what we have got? We have got bulk modulus K is equal to hydrostatic stress or stress divided by volumetric strain. Then we have got C tau by shear stress by shear strain, and another elastic properties, that is Young modulus, we have got sigma by E, stress proportional to strain, then hydrostatic stress proportional to volumetric strain, then shear stress proportional to shear strain. So hydrostatic stress proportional to volumetric strain, which is termed as bulk modulus, then shear stress proportional to shear strain, we have got modulus of rigidity, and stress proportional to strain, we have got Young modulus. Okay, so these three elastic properties we have got, elastic constants. So we will find out the relation between these different elastic constants. Again, another Poissons ratio will be there, mu. So relation between the bulk modulus, modulus of elasticity or Young modulus, modulus of rigidity, and mu. So we will find out the relation between these four. Okay, so hope you have understood. So next we will move for relation between different elastic constants. Okay. Thank you.